make an assembly from part assembly. And we have a variety of things that are sitting in my background here, but we'll start off with the shaft square. Click on this and then click in space here. Now, one thing we should do is make sure that this didn't just get placed randomly in here. I want the front plane of this to line up with the front plane of the assembly, and I'll show you why later. But I want to mate the front plane here with the front plane there. Okay. It says that these are fixed or fully defined. Well, see, it came in at this funny distance from the front plane for no apparent reason. And then it's telling me they can't put it in there. The reason why is when you bring in a first component, it automatically makes it fixed. So I'm going to right click on it and make it float. Now I can put them together. So I want the front plane of the assembly to line up with the front plane of the shaft. That's better. And I want the top plane of the assembly to line up with the top plane of the shaft. And I want the right plane to line up with the right plane. There we go. Now, you could also use the origin and possibly even a coordinate system to do that, but this will work. Now, happy with that. Notice how it does not show either an F or a minus sign here. Next step is to insert the hex example. So click here. I'm going to click here. Notice how it already comes in roughly oriented the same way as the square shaft, and that's because we tried to set it up that way from the beginning. So, well, if there was an offset, these just happen to have the exact same dimensions here, but if there was an offset, as there often is for inserted components, I wouldn't want them to be one right on top of the other. So what I would like to do is use the temporary axes of this. See, this is cylindrical, but this isn't, so I don't have any temporary axes for this. So I'm going to have to use, again, their planes. So I'm going to go to front plane of this and front plane of that. Hit the green check mark. Top plane of this with the top plane of that. Check mark. And then I'm going to have to pick the surface there, and I can't see, oh, there it is, that surface there, and there we go. I'm going to show you one more cool thing that we can do with SolidWorks, and that's using this button. This is the section view, and since I set things up for my front plane, top plane, right plane in my assembly, I can use this a little bit more effectively. It defaults to the front plane, so I'm going to rotate this around and I can see where my different parts are, and I can see the cross sections. Once more, I can move this so I can see more. You can do this in your parts as well, but I find it very handy to see how two parts are assembled and if they're assembled in the way that I want them to be. Okay, so we're going to save this as an assembly, and then we're going to bring it in and create a new one. I see this as a part that you might have made at a contractor. So they may have sourced the metal, they may have made the hex part and then welded them together. We can put a weld on here actually. We can go to Assembly Features, Weld Bead, and then I think those fillets are causing some troubles here, but that's okay. I guess we'll just get out of making the weld and leave that to the student to get rid of the fillets and to try to add welds in them. Okay, let's save this and move on to a new assembly. And we have a new assembly ready to go, and it's been saved. So we're going to start with the screwdriver handle. So click once there, and then we can click out here. And notice how it comes in fixed again. Let's fix that fixed. Right click and float it. Then mate it such that the front plane of the assembly mates up with the front plane here. Top plane of the assembly, top plane here, and the right plane of the assembly, the right plane of the handle. Okay, that may yield some benefits later. Now, we don't always have to insert another part. You can insert an assembly into another assembly. So make the first one that I mentioned a sub-assembly. Here's my shaft assembly example. I'm going to bring it over here. Now, notice how we did not design these parts in the same orientation that we did here. So it does cause a little bit of confusion, but it shouldn't be too bad. First, I wanted to show you something important. Going to mate this surface here with this surface down here. Problem is that this surface here is beyond some other surfaces. So I right click on top of it, go to select other, and you'll see that there's this face that's down beneath, and then there's the one we want, and then there's even one beyond that. So I want it to be on that face there, and oh yes, this did move. So now that face will always be in that plane. I can still move it back and forth and around, but it will still be on that plane. My next stop is to mate the front plane of the screwdriver handle with the front plane of the shaft. Okay. And then I have one more set to go through. Oh, wait a minute. I can use my temporary axes and go with the axis of the handle and the axis here. And now it should be all set. Notice how since the end of the other part of this video, I took off the radii here and added a weld on these surfaces here. In fact, that weld is a little distracting, so I'm going to go into the weld folder here, right click on it, and I'm going to simply suppress it. It doesn't go away altogether, but it suppresses it. Now I'm going to go back to view, take away temporary axes, and here is my finished assembly. Now there's another neat tool that you can use here. I'm going to show you. It's called interference check. And so we should have interference of these tabs with the plastic overmold of the handle. So let's go check that out. We're going to go to Tools, Interference Detection, and click on Calculate. And you'll see that we've got two places of interference, exactly as designed. So now all we have to do is save this. And usually you want to save all of them. And that's pretty much the end of this section. For this video, we designed this shaft as well as the tabs using some basic construction techniques. Then we also designed this part of the shaft so that it would fit in here. We put a weld on, we put fillets on, and used, again, some fairly basic techniques. Then we assembled the two and tried to make sure that we had the front faces and so on lined up, as well as lined up with the assembly front, top, and right planes. Then we showed that we could use a sub-assembly to be placed into an assembly as well as parts. So we used our right-click select other to find the correct surface, and then we were able to put the shaft, no problem, into the handle. And finally we did a interference check to make sure that the tabs were doing what they had been intended to do. Next up, we'll start making bits for this screwdriver and show how we can use that in different configurations.